Welcome everyone. So it's again not Sunday but Saturday. We're gonna stream. We are here in the office, Microsoft Office. So yeah, stream will be pretty short. So let's start straight away. So a couple of news. If you haven't been to previous stream, couple of news related to that. I was sharing with you the interview experience for my friend in Meta for production engineer position, which is basically site reliability engineer. So my friend got rejected. However, he got all interviews pretty much solved. So it was coding and Linux troubleshooting, and the Linux troubleshooting was the pretty interesting one that I have never heard about before. But yeah, it might be different reasons behind that. Starting from that, there was just a better candidate. There was just a candidate that already was far away in the process, and they already kind of accepted him. Bunch of reasons, but let's not focus on them. So, what we're gonna do today? Today gonna be just two questions for the heap and priority queue, and yeah, hopefully about the other news. I'm completely switching to Python from JS, because before that I was solving pretty much all the problems using in the JavaScript. However, my main is .NET C#. I feel like JavaScript is much faster in terms of producing the code and much more convenient than C#, because C# is kind of cumbersome. It's good for production code, it's good for readability, and it's good when you're writing the C# on the specifically designed IDE for that, for example Rider or Visual Studio. But yeah, other than that, C# is very bad for LeetCode, as my personal opinion. But once I got a bit used to Python, now it feels very smooth, very nice experience. So yeah, this is about the news. And another thing also what I would like to share with you now, yay, we are 1.5k subscribers right now at the moment. If you haven't subscribed yet, please do that. Once I'm done with this preparing to interview, and I'm maybe a bit, we'll start creating some content once I have some more time for that. Because yeah, at the moment I'm a bit stopped on producing the regular content. Instead, I'm just streaming weekly, and that's it, because most of my time is right now dedicated for LeetCode to get back my skills, some system design, and also I'm a bit overworking at the moment for Microsoft, because yeah, we had a couple of very important and high priority items. Yes, so this is also good news, celebration. Let's do 2K soon. Yeah, I would say that's it for the news for now. And let's go for the LeetCode. So the task. Smallest number in infinite set. So you have a set which contains all positive integers, 1, 2, 3, 4, 5, blah, blah, blah. Implement the smallest infinite set class. It should contain all positive integers. Good. Pop smallest removes and returns the smallest integer. Adds the positive integers back into infinite set if it's not already in the infinite set. So the explanation is pretty simple. So we're adding add back. So like imagine initially you have this infinite set that has all the numbers added into it, and you just starting working with it. So whenever you add in some item that is already in this set, you do basically nothing. It does not change any state. But if the number was already popped, it gets added and it will be popped the next. So what do I mean by that? Let's say here we are adding one, or no, I don't know, add back. What the hell is going on here? Yeah, we are adding 2. It doesn't do anything because our set starts from 1, and since that we have already 2 inserted into it. Then we do pop smallest, it returns 1, next pop smallest 2, next pop smallest 3, then we're adding back 1, and now our set becomes something like 1, 2 and 3 was popped before, and 4. So that's why the next one popped item will be the 1. So yeah, pop smallest return 1, and then it should be 4. So how gonna we implement it? There is one kind of trick for that task, is to look into the constraint. And constraint is pretty light one. We only have 1000 items, which means we can start our initial infinite set just with 1000 items, and then at most 1000 calls will be made in total to pop smallest and add back. So this naturally feels like heap problem, because yeah, we want to know the minimum element in a particular subset of items, and whenever we are removing this item from the subset of all the items, we want to know next minimum value in the least time complexity, so not linear possibly. Yeah, so it sounds already like a heap. For those who don't know, or it's not sounds like a heap, it sounds like a priority queue, but we're gonna implement it through the heap. So how does it work? Heap usually is represented via tree. So we have some tree, I don't know, can I draw here? Yeah, I can here. So yeah, it usually represented as a binary tree, or maybe not even binary tree, just as a tree. So the heap, no, actually it's binary tree. So the heap data structure is pretty similar to binary search tree, but the invariant here is the following. The top element is always the minimum element in case of min heap, and always the maximum element in the max heap. And the invariant is the following. All the items below, so all the children, in case of min heap, minimum heap, they should be less than this root. So that's the invariant. And in this way, we can just take the current heap in constant, just get this item, if we are talking about pick operation. Oh, hell, I want to also adjust so you can see everything, right? Yeah, you can. So with regards of pick operation, it should be constant time, but the thing is, once we pick this item, like in case we want to pop this item, so pop, which means return it and also remove from the tree, we need to reorganize this tree again to meet the invariant. So we should put to the root the minimum value that is currently in all of these items, and this can be done through the log n complexity due to how heap tree works and how heapify operation works. So the first trick for this task is the following. We have only 1000 items, so what we basically can do, we can just add the all items inside, and after that easy, we're gonna also have how to say, yeah, I'm a bit lost. So in our init function, we can just add all 1000 items straight away, but let's first implement our add back function. So our add back function, what do we need? First of all, we need some set. This is to control duplicates insertion, because let's say we already popped 100 items. So right now we have items starting from 100, 1 to 1000. What is happening next? Let's say we have add back 2, add back 2, and add back 2. And we don't want to add back 2 twice into our heap, because then it will be popped twice, which we won't actually omit because this is infinite set. So for that we keep uniqueness through this set. Then we have our heap. Yeah, and I guess now what we're gonna do in our add back function, that first we check if self set has num, and we just return and do nothing. If it's not in our set, it means it can be safely added. Then we do heap q heap push to our heap, and item gonna be num. That would be it. And now for initialization, we are doing in range from range should be from 1 to 1000. So 1001 is the exclusive upper boundary at the moment. And what we are doing, we're just calling add back and this number. So our heap is populated, and now for pop smallest, what are we doing right now is we are extracting the minimum element from the heap, heap q, heap pop, I guess this is the function, self heap. Then we are removing this item so it can be added back later from the set. I think remove is the right API, I hope. And we return the element. No, don't do this. That would be pretty much it, right? Should be working. Let's try it. Later on we will create a bit more optimized solution for better constraints. Self-set. Remove. Yeah. Yeah. We also should check if our length of heap is more than 0. Oh, sorry, if it's equals 0, we just return none. I think that this is the error. This is the problem. Still not. Okay, so what is the problem? In that case, okay. I guess this we missed adding to our set the num here. That's why it cannot find it in its rows exception. Yes. Good. The code works. The time runtime is not the greatest, as you can see, but it can be improved. Actually, we don't need to populate everything in our init function. In general, what problem are you working on? They ask in the chat. So this is the smallest number in infinite set. We are moving through the LeetCode 75 questions at the moment. So yeah, in previous streams we solved all of these cheeky-bricky problems. So what is time complexity? Apparently add back function. Let's we are doing 1000 times, which is our n basically in this case. Let me open it up. Yeah, sure, go for it, Solve it with us. So yeah, our input in this case is gonna be 1000, and 1000 of times we are performing add back, and add back in this case gonna be log n due to heap time complexity constraints. So this function basically is log n. Always. So yeah. So yeah, worst case it will be log n, and this thing adding it to set it's constant. So basically we are bounded by heapify heap push. And it means that basically this is gonna be n times log n time complexity, and also for the space complexity it's gonna be O(n), because we are populating our queue with all the items, so it's not the greatest solution. What is the much better solution? I will show you. So instead of pre-populating this thing, what can we do? We can maintain kind of counter. So let's name it current, which starts with 1. And instead of, yeah, this should be basically empty. Let's re-implement everything. We don't need to pre-populate it. So how our pop smallest would work in this case? Yeah. So if length of our heap at the moment is equal to 0, what we are doing, we're just increasing, first of all, incrementing, sorry, our current to the next one, and we're returning self current minus 1. That's it. Then else, and our else comes from the add back function, because add back function gonna change the state of heap and set. So if add back happened and we have our number which is less than current inserted here, we want to go our usual way with the heap, which means we are doing element heap q heap pop self heap. Then we're removing this element from the set, and we're returning element. And current is not changed in this case. Then add back function. If our num is more than current, then we basically don't change anything. We don't need to change our state. So in case we have our set this starting from 1 and we want to insert 3, our current going to be equal to 1, and 3 is not needed to be inserted. It will be popped later. So it's not the problem. But if we have the state that we have our set starting from 6 at the moment because it was popped before, and we want to add 2, then our heap and set gonna have 2. And this is the next element that's gonna be popped here. Oh, sorry, here. We're gonna pop it, we're gonna remove it, and then our set and heap gonna be empty, and we continue with our current counter basically. So yeah, in case it's less, what we are doing, we are adding it to set. Yeah, we also should check if num in self set. Then we also don't do anything. Otherwise, self set add num and heap q heap push. Yeah, sounds like that. Let me just briefly check. Current, yeah, remove. Yeah, let's try it. Finally, a fellow Vim user. Yeah, boy, of course, Vim motions everywhere. I don't know, I started using it about half a year ago, and I'm so happy that I switched. Especially when you need to work on the laptop without keyboard. So you know this thing that, well, let me actually show you. In most of the keyboards, like before the Vim motions, the most important keys is the home and end, right? So to do it as quickly as possible, you're usually using like control to go between the words, not between the characters, right? And home and end to go strings. But anyway, like I'm doing moves of my hand here and there all the time. So now fuck it, I'm Vim Yeah, let's go. Yeah, it is accepted, and this guy has much better time wrong answer. Why so? Why so? So if self current +1 current, yeah, otherwise we are popping, removing the element, returning the element and back. If num, or sorry, more than or equal, because if it's equal we also don't want to add it actually. Yeah, now should pass. Nice, now it's a bit better time complexity, so let's analyze it. Yeah. So regarding the pop smallest, I think in the happy pass, if we don't have anything added back, this guy is at all constant time, but if we had add back that has number way before our self current, it will do this guy gonna perform of log n, this guy gonna perform constant, and this one is constant. So like worst case, this thing gonna be of log n. This is time complexity, by the way. This thing gonna be O log n as well. Why so? Because this is our upper bound, and for the memory complexity also worst case it can be all the numbers added back. So space complexity is still of n. That's it. Let's move on. Just checking the question. Don't you need to add back even if greater than car? Sorry, let me get back. Don't you need to add back even if greater than car? No, I don't, and I will explain why. Let's say we already popped 3 items, I don't know, and right now our set should go like this. And let's say we are getting function add back with 5. If we add it, then our heap gonna be having 5, and set as well. Let's just assume that set is just only helper data structure in this case. Yeah, and we're gonna basically pop smallest. We go this if, oh sorry, we go this else, because it's not empty anymore. We doing heap pop, and instead of 4 we're gonna get 5. However, we should get 4, so that's why. You fixed it already. I meant greater than equal. Yeah, good, thank you. Then we are on the same page. Let's go. So maximum subsequence score, and this task, okay, I'll be honest with you, first time I didn't solve it on my own. It was maybe 4 months ago, just when I started my preparation. So let's read the task, because yeah, for me this one wasn't that trivial, unfortunately, or fortunately, I don't know. Sometimes they are like really trivial, sometimes it takes some time, to solve them. I think I answered everything right in the chat. Oh, we have 2 people watching on the Twitch. Usually it's always 1 people, I don't know. Oh, sorry, 1 person. I don't know, like YouTube somehow performs much better than Twitch usually. Oh, that's it. Yeah, what are you prepping for? At the moment, I don't prep to anything specific. The thing is that last time I was solving LeetCode was 3 years ago, when I just joined was preparing for the interview at Microsoft, and that's how I basically joined Microsoft. And since that, I basically forgot how to solve LeetCode questions, and I just want to get back into the form, especially on the background of layoffs. Because I don't know whether you heard or not, but Microsoft did, I think 1 month ago, Microsoft did pretty huge number of layoffs. Overall, it is like 5 to 8K of people laid off. So yeah, I want to be just up to date and be ready, just in case. So we are doing LeetCode and system design at the moment. Yeah, don't forget to subscribe to not miss. Next week we're gonna we're gonna stream maybe from the terrace in the office, because right now it's pretty warm. The reason why we're not streaming from the terrace is that it's dark outside. I started a bit late. Thank you. So maximum subsequence score. Yeah, this one is pretty not easy to solve problem for me. It was. So we're given zero index integer arrays nums1, nums2. Good, we have them. Nice. They both have same lengths. Good. And a positive number k. You must choose a subsequence of indices from nums1 of length k. So we should choose a subsequence of indices nums1. And subsequence is, yeah, this is very handy, by the way, because otherwise I will go to Wikipedia to double check. So subsequence of indices of an array is a set that can be derived from a set by deleting some or no elements. It basically means that we don't have to maintain the order and we can reorder collection as we want. So for chosen indices, your score is defined as the sum of selected elements from nums1 multiplied with the minimum of the selected elements from nums2. It can be defined simply as we have sum from I to k and then multiply from minimum number among all the numbers in nums2 from I to k, yes. Return the maximum possible score. So yeah, before we going deeper into that, let's think about it a bit. So what we actually want to achieve, in which case our score will be bigger. So our score is defined as n1 plus n2 plus n3 and so on times minimum n1, n2, n3 and so on. So our score will be bigger in the cases when we have, since all of them are positive integers, so the more we have these guys and the bigger these guys are, the more is the score, right? So we want this n1 plus n2, actually it should be m. These are completely different numbers. So we want n2 and plus n3, we want all of them to be as big as possible, right? And also what we want to have these guys as big as possible, because we're gonna choose the minimum one from them. The problem here that even if we have one single thing that is much smaller than other m's, in this case, you're gonna ruin all of our score, because if we have minimum like 1,000, oh sorry, 150, 101, and somewhere in the middle we have, I don't know, 2, it will ruin all of our summation. No matter how big these guys are, we're gonna multiply them only by 2, not by 50. So we should be careful with choosing the right algorithm how we're gonna do that. But overall, yeah, the greedy thinking here should be that we want as big as possible numbers from nums1 and we want as big as possible nums from nums2. You will go to hint section. I think they are mentioning that you should choose sorting, right? Because if you want to greedy pick up the biggest numbers, this is what you should do. So basically what we're gonna do, we're gonna sort these two nums all together. We're gonna use tuples. Once we sort them by nums2, because we want to have as big as possible multiplier. So in this case, let's say we have this guy, this is nums1 and this is nums2. So they're gonna be sorted as this. So two gonna be placed here, 2, and for sure then 1 gonna be placed here. So this is how we're gonna proceed. We're gonna go from the highest nums2 to the lowest nums2 to have the biggest multiplier. Why not 2 heaps? And how we're gonna use 2 heaps? I mean, maybe this is actually a good thing. I just know the one solution we can sorry. Is the stream working on both platforms or not? Because Restream is showing some weird thing that I have only connected YouTube. What the hell? Yeah, I just hope everything works as expected. Yeah, why not 2 max heaps? Because they two should be the same number. So you should choose the same indices. So whenever you choose, let's say you're choosing second index here, right? It means that for the minimum element, you should choose also second index here. But if you're keeping 2 different heaps, indexes will be messed up, and your number from heap 2 will not have same index as number from heap 1, and that's why it will not work most probably. Yeah. So yeah, how do we do that? We sorting these 2 arrays by nums2, and then what we're gonna do, we're gonna keep heap for the nums1 array, because since it is subsequence, we can basically drop any number. So if we have chosen, let's say, let me add, I don't know, let this guy be 1 and this guy be 5. So whenever we come to the point that we have, like, let's say our k is 5, whatever. So whenever we came at the point that we on number 5, or let's say k is 4. So we are checking this range, and then we want to move to this range. So instead of removing element 2, we want to remove the lowest element, because we don't have to like remove it. It shouldn't be the contiguous array, right? Because it's subsequence. So we want to just remove the lowest possible element, which is 1, and keep 3, 2, 3, 5. Because this way it will be bigger sum comparing to having sum 5, 3, 1, 3. This is going to be the idea, and yeah, this way we're gonna just scan the whole array and just scan contiguously k elements, I mean k window, and just slice it from the end to the start, and yeah, meanwhile maintaining the heap. And whenever we have more than k elements, we will just remove the minimum element from the nums1, and the minimum multiplier in this case gonna be just the currently explored index in nums2. Why? Because it's sorted. So whenever we exploring these guys, we know that if we add this index, no matter what is happening, our minimum multiplier among all of the sum that we are performing is 2. So this is going to be the idea roughly. Great, so exactly. So how are we gonna do that? First of all, we need to sort these 2 arrays by nums2. And how we're gonna do that? So let's define some sorted array, whatever. And what we want to pick, let's pick some tuple, and tuple gonna be nums1i, nums2i for I in range lane nums1. So we basically traversing all the right now we don't sort it, we just create the array of tuples. so we don't have to deal with these indices. It will be much convenient. And now we are doing sorted array sort by the key, and this is the interesting thing, because here we gonna just, yeah, I think this is the correct syntax because I'm not proficient with Python. So we want to sort it by the second element in tuple, so by nums 2I. And also we want to set reverse equals to true, because we want to scan from the highest to the lowest. Right now we're defining also our heap, and we're gonna traverse it. So we have our n1, n2, right? In our sorted array, we also have our sum equals 0, and we have current maximum. Let's define it. I don't know what is the maximum number we might have here. Since it should be, okay, all numbers are positive, so yeah, max sum, let's do it just -1 as the default one. So right now, what we are doing, we are increasing current sum by n1 according to formula that we are given here. Also, what we are doing, we are adding it to the heap. Heap and n1. Then, if our heap has more than k elements, what we are doing, we should remove the lowest element in our currently accumulated k elements from the array nums1. So what we are doing, heap q, heap pop, heap, and that's it. This way we make it again the length of the k, and then if length of the heap is equals to k, we are calculating the maximum sum, which is going to be maximum sum, or current sum. Oh, sorry, we should also do current sum minus equal of this lowest element. Yeah, and current sum times n2, because current n2 is the minimum element since we sorted, right? And we're going from the biggest to the lowest. Good. And at this point, I think once we're gonna traverse all the sorted array, we're gonna have our answer here. Let's check it. Good, seems like working. Let's also submit. So another, sorry, I don't know what you mean. Anyway, we got it submitted and it works. So yeah, 38. So let's now analyze the complexity of these guys. So first of all, we have O1 space complexity, because let's actually start with time. So for time complexity, this will be O1 straight away, and sorting gonna be, I think this is in place sorting, so most probably something like quick sort is used. So unfortunately, it can be even O to the power of, so n squared, basically, for the quick sort. But yeah, it's Python. If we choose different sorting algorithm, it can be n log n, worst case. Then we are doing heap, this is constant, and then we just traverse this array once, so it's n. And every single time we traverse it, we're gonna perform some heap operation, which is going to be log n. So it's again n iterations, and in every iteration log n. So it's again n log n, so 2 times n times log n equals n times log n, since we remove all the constants. For the space complexity, unfortunately, since we are creating newly created array, we're gonna have O(n). That's it. from the time complexity thing. Do we need a heap? Well, I would say so, yes, we do. And why? Because if, for example, we have something like this, 3, 4, 1, 5. Here we have, I don't know, 7, and our k equals to 4. And this is nums1. Why do we need to keep heap? Because let's say we're traversing, yeah, it's reversed. So let's say we're starting from the end. So we got these 4 elements, we calculated the sum. So the sum gonna be 3 plus 4 plus 1 plus 5, clearly, right? And now we want to move and explore next item, which is going to be this one, but k will be more than 4 in this case, so we need to remove some element. And if we don't use heap and we just, what element we can remove? If we're using a sliding window approach, we're going to remove this item because it was kind of the right pointer of the sliding window, and we just move it one step back. So it's going to be this array, let's say. But this is not the good greedy approach, because what it will be resulted in, that we're going to be having 7 plus 3 plus 4 plus 1, whereas in the heap case, we're going to remove 1 as the lowest element, and we're going to have, instead of this, we're going to have 7 plus 3 plus 4 plus 5, which is apparently bigger sum than this one. So that's why we need heap. I guess we can move on to the system design. So previous time we explored URL shortener and we watched other YouTube video for this implementation of this system design approach. And we were not that happy about their approach. We found a lot of flaws. So right now I actually don't know what I should take the next for the system design, and this is what I'm gonna ask ChatGPT. So give me top 10 widely asked system design questions for the big tech interview. This is what we're gonna solve. So pretty random. Can you please share the link of this doc? Which doc? I'm sorry. This one. This is not shareable. This is Calidro. This is in my browser. Even I cannot access it from my another PC. So yeah. Or you want a link for the problem? I don't know. It's Googleable. 2542 LeetCode, and you will find the problem. So yeah, URL shortener done. We designed it and we also implemented it. So the implementation is on my GitHub. So if you go to repositories, blah blah blah, yeah, this is the public repository, and you can find URL shortener here if you want. We implemented it using the C# and created the load test. It's in Docker. Everything is included. No, sorry, Scalidraw one is not shareable. I mean, if I share the link, you will be able to edit, and this is not what I want to have. But yeah, in general, contact me in Telegram, and I think I can just somehow import it, export it from here and send it over chat to you via some file or something like that. But sorry, no, I cannot share the link. You will be able to edit. Yeah, I'm sorry, let's get back. So design a web crawler, topics be crawling, the duplication, distributed workers. Okay. This is a pretty interesting one. Can do. Rate limiter we also did. It's already done and implemented. Messaging system pops up. Slack, WhatsApp. Yeah, this one is what I was asking during the Actually, doesn't matter. Design a distributed cache system, Redis memcache. This is pretty, I would say, maybe trivial one. I mean, I know how Redis works, right? We're using it at Microsoft, and yeah. Design a distributed cache system. Okay, design file storage system, Google Drive, Dropbox. This one I have never touched before. Yeah, kind of interesting one. News feed system, Facebook, Twitter. This one I never implemented on my own. I mean, never designed, but I saw, I think Designing Data Intensive Applications book by Martin Clapham is covering this topic. So I kind of know how to do that search engine. And this one is interesting. Ride sharing, Uber, Lyft, okay, YouTube. This one is interesting. This one I think I will not be able to do because I don't know the core algorithm, how we can work with video stream. Interesting. So let's maybe do this list of system design questions. We can do it just one by one, why not? So basically, yeah, design a web crawler. This one what we didn't do before. So design a web crawler. Let's say, give me the requirements, func and non-func. Okay, as a classic system design interview question. Perfect. I'm impressed. Do I need this? Okay, let's leave it. Maybe I will take some pictures later on. Let's just move to other space. So, functional requirements, crawl web pages, fetch HTML content from public URLs, support multiple protocols, okay, URL discovery and extraction, parse HTML content and extract new links, normalize and validate URLs before crawling. What does it mean, normalize URL? I'm sorry, but I don't know. I know what is database normalization is, but what is... like case sensitive, case insensitive. But this is needed kind of for duplication now. Yeah, okay, makes sense. Yeah, this needs for duplication. Yes. Yeah. Good. Makes sense. Normalize validate URLs before crawling. Avoid duplicate crawling. Okay, this one can be done, no problem. Respect robots.txt. Okay. Not overload any single server. Okay, so it can be kinda, in a way it should be scheduled, right? Or one crawler can actually do it one by one. Also, say crawl data, so store on file system, schedule and prioritization, maintain frontier queue for new URLs. Okay, so there should be some kind of priority. Okay. Let's see, I want to check. Okay, non-functional requirements. So these define how well the system should perform. Scalability, support crawling millions or billions of web pages. Okay. Easily scalable horizontally. Okay. High throughput, X pages per second. Okay. Fault tolerance. If a crawler node fails, the system should continue functioning with minimal disruption. Retry file request with exponential backoff. Okay. Okay, no data loss. Okay, this actually is pretty enough. So we have a bunch of functional and non-functional requirements. So let's start with this one. Design a web crawler. We're gonna first design it on our own, and I don't think we're gonna finish this stream, maybe next stream. So yeah, we're gonna design web crawler. So, what I usually start with is with some abstract design, or maybe let's first, think about small scale. So, and the flow overall. So, how does it work? How like the Google search detects that there are new pages appeared? I don't know. Actually, what I'm doing, I'm always, whenever I'm adding a new article for my tech blog, I just go and paste it to Search Console in Google Search Console. So I kind of notify Google about new page that is appeared. But how the crawling tasks should end up in the Google search engine in general? I think this should happen by exploring. So some sites originally, how they work, that they are submitting the crawling tasks. So let's say there is let's say there is Reddit, and they implemented their system in the way that whenever you create a post, there is a request to search engine, Google Search Console. I don't know how it works. How is exactly the name? Google Search Console. At least this is how I implemented one of my pet projects for selling of the pets. Whenever the people create the post, I'm sending the URL notification, request to notify Google that there is new page and you should kind of explore it soon. And let's say, this task is here. Google Search Console gonna pick it up somehow. And during the exploration of this page, there are going to be some other links that are leading to other websites. And they're going to be added for exploration as well to Google Console. So this works some kind of like a graph, right? Because we're going to start with some entry. Let's say this is the Reddit. And during we are exploring the Reddit, we found out some another websites. Also, these websites also point to the Reddit, to each other. There is another website that points to this one. So I would say this is something like a representation of direct graph, but in a very large scale. Yes. how it works, that given some one node, we can basically explore a big chunk of the tree, and eventually by exploring more and more, and by more people adding their entries, we're going to explore the pretty much almost full graph. But there should be still the nodes that will be unexplored forever. Okay, this one we kind of understood. So let's say the task for exploration is going to be submitted by the user, by some site owner, or by already running crawler job, right? This one we agreed on, I guess. Okay, so now let's create some kind of high-level design at the first time. So yeah, there is our system and there is incoming request. So incoming request might be by some website owner or by another crawler, or I don't know, another crawler node. Let's name it node. So these two guys can add the task. Now, should we somehow validate the task on the initial level? That, for example, yeah, I guess we should. So the flow pipeline should be something like the following. We have validation here, so they're going to be validation. By validation, I mean this URL normalization. So first of all, we are doing lowercase. Then we are removing like maybe some ports if they are default ones, rearranging the query parameters. This all thing needed basically for avoiding duplication. So that if two different URLs with exactly the same parameters but ordered differently, maybe lower, uppercase and stuff like that. So we just actually map it to the single one. So the output from here gonna be just validated URL. Then we should do another kind of validation when we have a ready-made URL. The crawler, what it should do, we should check whether there is already crawled. Let's say we have some storage, it can be cache, whatever. We're gonna check visited. Is it already visited or not? So if it's already visited, then we kind of should also this is an interesting question for the functional requirements. How frequently we should revisit already crawled page? And is there such thing like forced recrawling, which means, okay, our policy is to revisit already crawled page every month, but we have some premium customer that wants it to do like every day manually and forcing it. So crawl fetch, okay. Extraction, duplicate, yes. Respect robots, okay. Content storage, okay. Scheduling and prioritization. There is nothing said about okay, so the duplication, okay. No, it's different thing. So yeah, this is the requirements. Okay. Support protocols, HTML normalize, track visited. See it. Okay, let's just ask it when I should crawl ready crawl page. Okay, let's say we want to recrawl, so even if it is visited, we still should check that, okay, let's say if it's visited but it was visited like 1 month ago, we're still kind of gonna revisit it again. Yeah, or also we can check if it's visited, but if it's high priority, which for example can be set by manually customer submission, then we also gonna check it. But yeah, okay, if it's visited plus some heuristics are used to detect that we can proceed even with visited node. Then if it's visited and we decide not to move forward with this link, that's it, the flow is ended here. Otherwise, what is going to happen now, I think we are kinda right now on some master node or something like this, so it's not crawling job yet. So we're gonna assign this task to some crawling node. Assign to some node. Boom. Yeah, and now node should go and parse this website and potentially create, not potentially, it will create new URLs if it finds the links on the pages. It's gonna crawl the specific URL. Yes. And after it crawled it, it should store the content in storage. This is gonna be content storage, which is, yeah, the parsed HTML gonna be stored here after crawling node parsed it. And also what it's gonna update the visited, because now we are say the particular URL to completely revisit it with the date UTC now or whatever. The task is done, basically here. Task is done. I guess this should be the flow, basically. This should be the flow. Now let me get back to our requirements. So first, functional requirements. We should align with the flow, and then we're gonna proceed with non-functional, billions of requests, blah blah blah, all this bullshit. So this one is kind of covered by the node implementation. This one is also by node implementation. Track visited, yeah, we have it in our storage. We're gonna not do it only in case of recrawling or high priority. This is also the code base of node implementation, so we don't care about this. Overload any single server. So this problem can be solved actually by assigning some specific domain only to single node, so it should be exclusive assignment. There's gonna be some master node or whatever which gonna assign the URL to specific node for parsing, and this assignment should be exclusive. So once node received the task, it's done. No other node can receive this task, and basically the URL, which means I'm not gonna traverse it, let's say, sequentially. So just basically no, actually, yeah, this is an interesting task because only one URL, we cannot in general overload it. Yeah, but yeah, still, what we can do is that maybe we can assign node based on the URL. I'm just now wondering, should we keep a task as a single URL to be parsed, or we should keep task as a parse the whole domain? I guess no, parse the whole domain might not work because, you know, it can be reddit.com and you parse a lot of things. So maybe better choice would be to parse URL. Now, how to not overload it? What do I mean by that? That let's say this guy explored 50 more URLs and all of them got again to this start of the flow. And what happens the next? They can be redistributed between different nodes, and now it can be the situation that 50 different nodes are actually going to parse same site, and we're violating this requirement. So this is actually interesting question, how we're gonna overcome this. I'm now thinking that actually, yeah, there should be some master node that assigns but also it's kind of bullshit because let's say we are parsing Twitter, right? How many Twitter posts created per second? It can be a bit bullshit requirement because, yeah, imagine there is Twitter, and let's even assume that Twitter is public, right? It can be some website, whatever, or newspaper, let's say. And Twitter creates 5,000 tweets per second. And if we assign only one domain for one node, it will just not yeah, it will not catch with the load. So it will be constantly overloaded because for sure the node cannot process 5,700 URLs per second, one single node. You should like get the HTML, parse it, create additional tasks for another URLs and things like that. So I guess, yeah, we shouldn't do that. So it should be actually configurable per website or per domain actually. And this configuration can be settled actually. Maybe we can store this configuration, like how many concurrent workers can work on the same domain. And we can kind of maintain this counter somehow. And if this counter more than something, yeah, we basically recreate the job and put it again to the queue from the start, so it will be picked up later. Yeah, so this is one potential solution, right? So we can have we can maintain, it also going to be done by some master node or whatever. You can maintain table of assignment that, let's say, I don't know, Twitter, or at the moment it's x.com. It allows, I don't know, 1,000 workers working at the same time, because, you know, you should have a lot of workers to catch up with the load of 5,000 tweets per second. Yeah, and whenever we got this task going here on our pipeline, and we're gonna assign node, we're just gonna go here and check whether, yeah, if there is already 1,000 node, we're just gonna throw this task away to the queue again with some lower priority at this time. And once, I don't know, a couple of nodes will be done with this, so let's say it's gonna be 9, 9, 8, and this task again came into our pipeline. We see that it is less than 1000, so we're increasing atomically. Let's say it's some radius atomic increment operation. Yeah, and after the increase, the task gonna be assigned to some node and it's gonna start processing. This is one way of solving this problem. Yeah, but overall it should be dynamically configured, right? And it's very hard because it can be some single site, right? They just posted a bunch of pages and submitted them for crawling. And let's say this site is running on some Raspberry Pi, one vCPU to, I don't know, 4 GB RAM with some heavy PHP WordPress shit. It will just be overloaded by 10 crawlers, right? So it should be, yeah, configured dynamically. Dynamically, maybe we can come up with some algorithm that depending on the number of pages that we are crawling per second for this website, we changing the number of concurrently working nodes that are passing this domain. Okay, content storage. This is kind of trivial problem. Scheduling and prioritization. This is quite interesting problem. Actually, in order to check that this can be satisfied, I should check how the Kafka and some famous queue storages are working, whether they support prioritization of the items or not. Because, yeah, if we are not talking about distributed environment, prioritization in terms of one node can be solved easily. It can be just in some RAM memory, right? You could use heap if you can fit it in a RAM, and that's it. You're gonna just get always the highest score task, and that's it. But with the distributed environment, I actually need to check it for the next stream. Optionally prioritize, but it's optionally. Okay. If it's optionally, let's not take care about this. Support for distributed crawling. Distributed workload across multiple crawler instances. Yeah, that makes sense. Okay, so I think this should be it for now. So kind of problems that I would need to investigate is how to do prioritization in the right way for distributed environment, because all of this right now can be scaled pretty well. The only one thing is, yeah, there should be one master node that assigns it in order to be consistent. We don't want two nodes to be parsing same page. We don't want to have duplicates. But this can be solved by different layers of deduplication over the pipeline. Yeah, I should think about who and how. Okay, let me use text. Who and how assigns the URLs to nodes. This can be our bottleneck for the distributed scaling. The number of nodes scales easily. You just set up new instances and tell your master node that they are ready to pick up the work. So number of nodes for parsing is not a problem. Then what we also have, we have visited storage. I guess mostly it will be for read, so it will be read heavy. Because what we're gonna do, we're gonna go here, check whether there is node, some URL and the time. And then based on that, we decide what to do with it. So yes, this can be some cache, most probably distributed cache like Redis, with just two fields like URL and last time visited, maybe priority also. Most of the time we're gonna visit, so maybe some, yeah, first of all, partitioning by URL hash, which can easily distribute the load. And then, yeah, for fault tolerance, default replication master leader, and that's it. Yeah, then for this table of number, yeah, let's maybe solve the easiest easier problem. For the content storage, it's also kind of easy. Should be, first of all, we partition it 100%, also by URL hash. It's gonna have just URL to content mapping, URL to content mapping. And since it's partition, we can narrow it as much as possible. Good. Yeah, so also trivially solved problem. Now for this table that maintains the how many concurrent nodes can be parsing the particular URL. Also can be partitioned by URL, so pretty much everything gonna be partitioned by hash URL here. Yeah, and since it's gonna be partitioned, we also can slice it as much as possible, and I don't think there's gonna be more than 5,000 requests per second. Also, we're gonna have some rate limiter on top based on hash of the URL as well, so we can kinda, you know, validate it before and throw away unnecessary requests, so we are not afraid of getting overloaded here. So yeah, that will be it. And yeah, right now pretty much the only question I'm gonna be researching for the next stream is how we're gonna proceed with this assignment of the nodes. Oh, sorry, tasks assignment to the nodes, or URLs assignment to the nodes. Yeah, next stream we're gonna continue. So yeah, thank you everyone for being with me. I think that will be it for the stream. It was enjoyable to stream together with you. Thanks for being with me. Subscribe to all social media to not miss next stream. I'm posting all the necessary details there. And have a nice one. Bye bye.